The cosmos is vast, beyond our wildest imaginings. For all of human history, we have gazed up at the night sky, a familiar canopy of stars and planets. We learned their names, tracked their movements, and felt a certain comfort in their predictable dance. We sent our robotic explorers to its far corners, mapping worlds of ice and fire. Then one day something new arrived. It came from the dark, silent expanse between the stars. It was October 19, 2017. A telescope in Hawaii spotted a faint glint moving rapidly. At first, astronomers assumed it was just another asteroid or comet, local debris, but as they tracked its path, a startling realization dawned. This object was not from around here. We named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. It was the first object of its kind we had ever seen, a true messenger from the stars. We scrambled our telescopes, pointing every available eye toward this fleeting visitor. The encounter was brief, a cosmic handshake that lasted only a few weeks. By studying how its brightness flickered, astronomers deduced an extraordinary shape, long and thin, radically different. Nature doesn't usually make objects with such extreme proportions. It was a cosmic needle among round stones. We pointed our most powerful telescopes expecting a comet's telltale coma and tail, but there was nothing, no gas, no dust, no tail. It was completely inert. Its dark, reddish hue suggested eons of radiation, a relic from another star system. And it was tumbling, a chaotic end-over-end motion implying a violent past. In the face of such a strange visitor, the scientific community did what it does best. It started guessing. Some proposed it was a shard torn from a planet by tidal disruption, a dramatic but plausible idea. Others imagined exotic ices, solid hydrogen or nitrogen that might not leave a visible coma. An invisible gas tail is conceivable, but it requires an object we have never observed forming naturally. Maybe it was incredibly porous, a cosmic dust bunny with density like nothing we've seen, or the charred remnant core of a comet that lost its volatiles long ago. Papers multiplied, each new idea trying to fit the data: shape, color, lack of outgassing, tumbling. Still, one piece always seemed to be missing. Then came the anomaly. With gravity alone, Oumuamua should have followed a predictable path, but it accelerated away from the sun slightly faster than expected, a tiny, undeniable nudge. The obvious answer was outgassing, jets acting like small rocket thrusters, but Hubble and the best instruments found nothing. No coma, no spectral lines. It was accelerating with no visible propulsion. That small fact changed everything. The clue that didn't fit any neat natural box. A planet fragment wouldn't accelerate on its own. A dry asteroid wouldn't have that mysterious push. A more radical possibility entered the conversation: solar radiation pressure. Could sunlight itself be the push? For that to work, the object would have to be extremely thin, a large area compared to its mass, like a sail. Some scientists, notably Avi Loeb, proposed a breathtaking conclusion. What if Oumuamua was not natural? If it were a very thin sail, sunlight could accelerate it. An explanation that elegantly accounts for several oddities. Its extreme shape becomes a design feature, its lack of outgassing sensible, its acceleration explained. This hypothesis is controversial. Extraordinary claims need extraordinary evidence, and we have none. The idea leapt out of academia into the public imagination. Headlines and debates followed. We already developed solar sail technology ourselves. It's not pure fantasy. As an artifact hypothesis, Oumuamua neatly ties together shape, color, invisibility of jets, and acceleration. Still, the evidence remains circumstantial, a collection of coincidences rather than a smoking gun. The notion suggests a new field, space archaeology. Instead of waiting to hear, we examine artifacts. Maybe the galaxy is littered with derelict probes, buoys, and sails, technological debris drifting between stars. We listened with radio telescopes. We heard nothing but cold static. If it was a probe, it could be dead or simply not interested in talking to us. This raises the specter of the Great Filter, barriers between life and long-term survival. Or, wonderfully, it could be evidence someone has mastered interstellar travel. Perhaps Oumuamua was a passive buoy, part of a galactic wayfinding system we're too primitive to read. We are like ants on a sidewalk, unaware of a superhighway roaring above. Its silence may be our infancy's mirror. The silence is, in its own way, more unsettling than a threat. It suggests we might be oblivious to galactic activity. For decades, SETI taught us to listen for a deliberate signal. Oumuamua suggests evidence may come as artifacts. Maybe we should practice space archaeology, search our cosmic backyard for messages in a bottle. How many more drift past us each year? New telescopes will reveal many more visitors. We need to be prepared to study, and perhaps visit these objects with dedicated missions. This is a call to exploration, to inspire the next generation of scientists and engineers. Whether rock or spaceship, Oumuamua taught us about our place in the cosmos, filling us with humility and urgency. The universe sometimes whispers, not shouts. These quiet mysteries force us to grow. Oumuamua has left our view, speeding away into the darkness. We will likely never get a second look. We are left with questions, debates, and a profound sense of wonder. Was it a fluke, or a glimpse of a galactic society? The cosmos awaits. Keep looking up, keep searching, because the darkness between the stars is not empty. It is full of messengers.